Welcome back. We are going to do isometric drawing today. And in this picture, we can see three sides of the object, the top and the two side views. And the important thing about isometric drawing is exactly that we can see the three dimensions of our design. So if we were to look at this diagram shows us the top, the front, and the side views, and you notice that the angles are equal on both sides. In this case, they're 30 degrees, which is what makes them iso, right? They're two of the same angles, like an isosceles triangle. So we will be using a 30 by 60 triangle for this drawing, and the triangle will have 30, 60, and 90 degrees. So if we overlay this drawing, we can see that the drawing lines up with the 30 on the ground line, the 90 in the vertical, and we won't be using the 60 that much. Okay, so just know that everything in an isometric drawing, all the same sides are going to be parallel in terms of their line. There are no converging lines like in perspective drawing or observational drawing. So here I have a top view and a side view of this shape, the letter L. And I am going to just draw a red line in the middle just to divide those two areas. But first I am going to draw in the ground line, and I'm bringing back the diagram so that we can keep track of the projection planes that we are going to be making. So the first thing we're going to do, we are going to simply just draw the box in which this letter L is occupying. And the thing about isometric drawing is that all of those sides are quantifiable, meaning that we can measure them and there's no distortion, right? So the left side of this object is going to have a value, and all the sides, in fact, are going to have a value that can be taken from your orthographic drawing. So as you can see, I'm just sliding the ruler and using the triangle on the ruler using the 30-degree angle, right? So now I'm just extracting all of the measurements. Once I've drawn out the box, I'm placing the divider and getting the distance from one point to the next, and we stick with that 30-degree angle. So you notice that in an isometric drawing, a box does not have any converging lines. All of the lines are parallel along the same axis, right? So on the y-axis, they're all parallel, or on the x-axis, it's all parallel. Along the z-axis, it's all parallel lines. Now that I've drawn out the footprint from the top, I can now bring in the height of this object, which is given to me by the divider. And I'm just making some construction lines going 90 degrees from the ground line. And that 90 degrees will contain a value which is the elevation or the height of this object. Okay, so there it is. So once we have that value, we can now put that in on the vertical line. And of course, in this drawing, this L shape is extruded, so it's designed so that we can just simply understand the concept of isometric, but in your design you may not have parallel extrusion, right? You might have sheared shapes, circular shapes, and so on. So we will cover all of those things in this series of isometric drawings. And now that I have all of the construction lines indicated, I can now go and do my outline. In our technical drawing, we only use the outline because there's no shading and there's no variance in the line weight, right? What we want to do is just represent the actual dimension of the shape. We don't want to create any kind of illusion of space that is perceptual. We want all of this to be quantifiable. So now even though this drawing makes it look as if the L shape is larger, we can now measure all of the sides in its 3 dimensions: the top, the front, and the side view. And if you need to draw the other side, then you would have to rotate the object and draw it from that side. Thanks for watching.